Hey everybody! Today we're going to be working on solving radical equations and inequalities. That is, we're going to be solving these equations with square roots. We're going to be solving for x and keeping in mind that the way to solve these is to isolate the square root. And then number 6 is going to be an inequality. So let's get started. So we have our first problem. Notice that problems 1 through 5, our directions are to check our solutions. So we may expect some extraneous solutions for these ones, but let's go ahead and solve number 1. So keeping in mind also that we need to isolate the square root, let's get rid or divide out the 3 from both sides. So we're left with the square root of x plus 25 equals 2. So now that we've isolated that square root, we can square both sides to cancel it out. And we're left with x plus 25 equals 4. Last step, subtract 25 from both sides, and we get x equals negative 21. But we're not done here because we have to check our solution. So we're just going to be plugging it back in to our original equation and seeing if it's true. So we have 3, we know that this is going to be 4. Simplify, and it becomes 3 times 2, and it ends up being true. So we can go ahead and box x equals negative 21, and we're done with number 1. Moving on to our next problem, we have the cubic root of x minus 3 plus 2 equals 4. So no matter what root you have to evaluate, we're always going to try to isolate it. So first step, just like the last one, let's get that cube root all by itself. That's gone. Now we have the cubic root of x minus 3 equals 2. To cancel out the cubic root, we have to cube both sides. So I'm going to go ahead and do that. Cubes are canceled, and we are left with x minus 3 equals 8. Further solving, we get x equals 11, but we have to check whether that's true or not. So plugging it back into our original equation, cubic root of 11 minus 3 plus 2, does this equal 4? Let's see. Okay, so we get the cubic root of 8 plus 2. Is it equal to 4? We know that this is 2. It becomes 2 plus 2. So far, so good. And it checks out, so that means we have our final answer, x equals 11. Moving on to number 3, where we have a variable on both sides, but still treat it the same. We already have that square root all on its own, so we could go ahead and square both sides right away. So while the left side might cancel out nicely, we will have to FOIL the right side. So starting with the easy part, we can cancel out the square roots. We're left with 44 minus 2x, and foiling out the right side, we get x squared minus 20x plus 100. Now let's move everything to one side so that we get a trinomial in standard form. I'm going to subtract the 44 and add the 2x in one step just to make things cleaner. Plus 2x, so we end up getting 0 equals x squared minus 18x plus 56. So now we can't leave our answer like that because we have to solve for x. So I use the x method of factoring because I like to visualize the two numbers that I need. But for this one, we need to think of the two numbers that multiply to 56 but add up to negative 18. And those end up being 14 and 4, negative 14, negative 4 specifically. So we have 0 equals x minus 14 times x minus 4. And then we could solve for x using the individual parentheses. So for this one, we do get two solutions that we have to check though. Whoops. X equals 14 and x equals 4. So plugging both in to the original equation. Let's check x equals 4 first. Just why not? Rewriting the original equation. Okay, so plugging in 4 for x, and we're trying to see if this is true. So we have 44 minus 8 equals negative 6. Square root of 36, does that equal negative 6? Well, we know that it can't be true. We can't take the square root of a positive number and get a negative number. So we can actually cross off x equals 4 as one of our solutions. And let's go ahead and do the same for 14. Making sure that this is in frame. 44 minus 2 times 14. Does that equal 14 minus 10? So we have 44 minus 28. Does this equal 4? And we do get the square root of 16 equaling 4, which we know to be true. So we can go ahead and box x equals 14 as our final answer. Okay, so moving on to number 4. With this one, we have a square root on both sides of the equal sign, and our goal is still to get the square root on just one side of the equation. So the only way that we can do that is we would have to square both sides. And yeah, on the left side, we do end up needing to FOIL two radicals together. So just gonna write out what we're really looking at there. But luckily, the right side cancels out. So we have just x minus 2 on the right side. So to FOIL the left side now, we're just gonna multiply all parts to each other. So drawing that out, the first part we have the root of x plus 6 times the root of x plus 6. So any root times another root just cancels it out. So we have x plus 6 as our first term. The next one will be negative 2 times our root, another one of those guys for the inner terms, x plus 6, and then the last ones are plus 4. And still that x minus 2 on the right. So now we can combine like terms, these ones, and I'm also going to move our constants and my plane variables to the right side. So that means I'm going to be subtracting x, subtracting 6, and subtracting 4. So minus x, minus 6, and minus 4. So that tells us that on the left side we get negative 4 times the root of x plus 6. and that all adds up to negative 12. So now we're looking at a problem that looks kind of similar to the easier ones that we did up above. So same thing, isolate the square root. Let's divide out that negative 4, both sides. We get root of x plus 6 equals 3. So to cancel it out, square both sides, or to solve for x, we get x plus 6 equals 9. Subtract 6 from both sides, and I'll put the answer up here actually. We do get x equals 3. But this is problem number 4, and we needed to check the solutions on problems 1 through 5. So we're not done until we verify that this is true. So plugging it back in to our original equation, we have 3 plus 6 minus 2. Does that equal the square root of 3 minus 2? So just evaluating, we have the square root of 9 minus 2. Does that equal the square root of 1? Well, we know the square root of 9 is 3, so on the left we have 3 minus 2, and on the right we have 1, which does work out nicely. So our final answer is x equals 3. And the last one that we need to check solutions on, number 5. So notice that it's x plus 6 to the 1/2. Remember that anything to the 1/2 is the same as the square root. So to get rid of this, we can just take the reciprocal of that exponent, which then is 2. So if we're going to be squaring or getting rid of that 1/2 by squaring it, we have to do the same to the right side. So the exponents are gone, and we have x plus 6 equals x squared. So I'm going to go ahead and put this equation into standard form, keeping our x squared positive. We have x squared minus x minus 6 equals 0. So FOIL it out. Two numbers that multiply to 6 but add up to negative 1. We have negative 3 and 2. So 0 equals x minus 3 times x plus 2. From there, we have two solutions. X equals 3, cutting corners a little bit here, and x equals negative 2. So we got to test whether these ones, or whether we get any extraneous solutions from either of them. So let's test out negative 2 first. We have negative 2 plus 6 to the 1/2 power. Does that equal negative 2? So we have 4 to the 1/2 equals negative 2. Well, kind of just like the earlier problem we did, we can't take the square root of a positive number and get a negative number. So this one does not work. So we can cross out x equals 2 as one of our solutions, but we still have to test x equals 3. So same equation, 3 plus 6 to the 1/2, does that equal 3? We have, so that becomes 9 to the 1/2, or the square root of 9, which we do know to be 3, and that works out. So our only answer for this one is x equals 3. And we finally made it to our last problem, our inequality number 6. So same idea in mind. Our goal is to isolate the cube root in this case and solve for x. So we can do that by dividing both sides by negative 2. But remember that since we're dealing with an inequality, anytime we multiply or divide by a negative, we have to flip the sign. flip sign. So on the left side, we have the cubic root of x plus 4, but now we have to flip the sign, so it's greater than or equal to -6, and we could solve from there. So keeping in mind that to cancel out the cubic root, we have to cube both sides. We have x plus 4 on the left equals -216. Study up on your cubic roots if you didn't know that right away. So last step to solve, subtract 4. And our final answer is x is greater than or equal to -220. And we don't have to check the solutions on this one. We're good to go once we have our answer. And that's it. Hopefully this helped with clearing up how to solve tricky radical equations and inequalities.